Hello everybody. In this video, we are going to see elaborately the ADAS ECU flow diagram or the flow chart. How are the actual data flowing in the ECU? From where to where development is happening, from which point to which point development is happening, we will see elaborately in this video. Now, we are going to see ADAS ECU data flow diagram for L2 and L3 automation. I already explained to you what is meant by L2 level and L3 level of ADAS. Okay, and this diagram outlines the data flow between sensors, ECU, actuators in L2, which is partial automation, and L3, which is conditional automation, and in a L2 system compliant with UNECE R157, ALKS and other relevant standards. So in the perspective of a automatic lane keeping system, we are going to see the data flow between the various sensors, ECUs and actuators. Now, to give you a system overview, you already know this, but just to set the context, L2 automation, in L2 automation, driver must monitor, for example, Tesla Autopilot, GM Super Cruise, etc., etc. And L3 automation system handles all the driving in specific conditions. In specific conditions, the system handles all the driving. So here the onus is on the ECU or on the computer. For example, Mercedes Drive Pilot. Now, in the key ECUs, sensor fusion ECU, it processes the raw sensor data. Central ADAS ECU, it decision making and path planning, and vehicle control ECU, it executes the commands. Okay, and when it comes to human machine interface, this is the human machine interface where the actual driver alerts, whether it is audio drive alert or video alert or haptic alert, all this happen through human machine interface. Now we will see in this table how the data actually flows. Okay, in this table, sensor is there, data output is there, and destination is there. We will see from which sensor data, which data is output, and to what is the destination of the output. All right. First one, front camera, the output is lane marking, traffic signs and objects. As I said, data front camera is majorly used in object identification and classification, and the destination of this particular data is sensor fusion ECU. Now when it comes to radars, object distance, relative speed, and the destination is sensor fusion ECU. All right, and when it comes to LiDAR, the output data is high resolution 3D point cloud, and the destination is sensor fusion ECU. And when it comes to ultrasonics, the close range obstacle detection, the sensor fusion ECU again is the destination. Now coming to IMU GPS, the data output is vehicle dynamics position, and the destination is central ADAS ECU. Again, when it comes to sensor, vehicle to everything integration, vehicle to pedestrian, vehicle to mobile, vehicle to vehicle, when this is the concerned sensor, and the data output is traffic signal, road hazards, construction zones, and the nearby vehicles at the T intersection. All these are the data output, and again the destination of the data output is central ADAS ECU. To proceed further, now we will see elaborately what is processing layer. All right. Now again here we are going to see the ECU and what is its function, what is the input and what is the output. Now when it comes to sensor fusion ECU, this combines sensor data and object tracking, and the input is camera, radar, LiDAR data, and output is unified environment model. So this is happening, unified environment model is happening after the sensor fusion. All right. Now next comes the central ADAS ECU. When it comes to central ADAS ECU, path planning and decision making is the function. That is this is the responsibility of central ADAS ECU, and the input is fusion data, GPS, V2X, and the output is trajectory and actuation commands. All right. So the output is the trajectory and actuation commands. For example, during the parking assist or when you are reverse parking, you can see a trajectory on your display screen on the infotainment cluster. That is the trajectory trajectory here which is talking about. Now coming to vehicle control ECU, executes steering braking throttle. The function is to execute the steering braking throttle, and the input is command from the ADAS ECU and the output is actuator signal. Now coming to HMI ECU, the human machine interface ECU, the purpose of that, the responsibility is to alert the driver to take over request. For example, the vehicle is driving in a level 3 and suddenly the vehicle understands that it cannot handle the situation, then it asks the driver to take over. Now coming to the input, this is the system status and the warning, this is the input, and coming to the output, visual, audio, haptic feedback is the output. Okay, I mentioned many times to you what is meant by haptic feedback. For example, tightening of the seat belt or sudden jerk of the brake, all these things fall into the category of haptic feedback. Now coming to the output layer, I am talking about the actuator, the control signal and the source. These are the three categories we are going to discuss about. And when it comes to actuator, the EPS steering, the electronically programmable steering, and the control signal is the steering angle command, and the source is vehicle signal ECU. And coming to the actuator, the ECU brake, when it comes to electronic stability control, the actuator is the brake, the control signal is the deceleration command, and the source is the vehicle control ECU. Now the actuator is throttle, control signal is the acceleration command. This throttle is otherwise called accelerator also. So the control signal is the acceleration command and the source is vehicle control ECU. Now when it comes to dashboard, this keep hints, the control signal is keep hands on the wheel or take over. These are the various kinds of control signals, and the source is HMI ECU. Okay, so this HMI ECU is the source of asking the driver to take over or keep hands on the wheel. Now when it comes to key data flow process, the step one is, I want all of you to see this drawing. This drawing is very important. If required, you pause the video and observe this drawing. This will clearly give you a step-by-step idea about the ADAS system flow diagram, from where to where the data is flowing, which is the actuator, which is the HMI, what starts first, what comes next, and again what comes next. All these things is very clearly identified in this drawing. Okay, now coming to the key data flow process, sensor data acquisitions includes camera, radar, LiDAR, ultrasonic, and they feed the raw data into the sensor fusion ECU, and IMU and GPS provides vehicle state. Okay, that is the sensors which clearly give the speed, the yaw rate and the position. And also step 2, it clearly indicates the sensor fusion and the perception, which includes the Kalman filters, the neural networks merge data for object detection and tracking, the lane, road and geometry estimation, and free space detection. Now when it comes to decision making, the central ADAS ECU uses HD maps and GPS for localization. It also includes the behavior planning, decides lane changes, stops and speed adjustment, and also this is important. When it comes to decision making, motion planning is the most important thing, because this is the one which generates the actual trajectory or the path of the travel of the vehicle. Okay, now coming to the step 4, which is vehicle control execution. This may require EPS, this may require braking, electronic stability control, and also throttle, actuate the planned trajectory, and this includes the redundancy checks, ensure fail-safe operations, and this also includes the fail-safes and fallback to the driver. And coming to the step 5, which includes the driver interaction, this is a very important thing, because this is the actual step or stage where the vehicle is warned. In the L2, the continuous driving monitoring, which includes the steering, torque checks and the eye tracking. Okay, and next coming to the L3, this issues the takeover request. This is important. Takeover request if the system limits of reached. If the system feels the situation or the traffic situation is beyond what it can handle, it will immediately ask the driver to take over. All right. So I hope all of you are getting a clear-cut idea about the flow rate or the flow path of the entire ADAS development. Now coming to the safety and redundancy considerations. So during development, what are all the considerations? Some basic considerations are fail-safe mechanism or fail operation design. If one sensor fails, others compensate. And when it comes to SLD compliance, critical ECUs must meet highly safety integrity, which is taken care by the ISO 26262. And again, the ISO 21434 cyber security is also clearly considered. Okay, now coming to the compliance with UNECE R157, it has to make sure the sensor redundancy, at least two independent sensors, and minimum risk maneuver. If the system fails, it safely stops the vehicle. This is extremely important because the vehicle is heavily dependent or relying on the computer. So if the system fails, it has to make sure the vehicle is stopped beside the road in a safe manner. Now coming to the driver monitoring, it ensures driver is ready to take over or alerts in the L3. Now coming to the conclusion, this ADAS ECU data flow ensures robust L2 L3 automation with sensor fusion, decision making and actuator control while complying with these standards, whether it is UNECE R157 or ISO 26262 or ISO 21448. Okay, thank you.